Today we will discuss about one of the most important name reaction of organic chemistry, and that reaction is Gabriel phthalimide synthesis. Gabriel is the name of the scientist who prescribed this reaction. Phthalimide is the compound from which we can synthesize 1 degree Na. So let us see how can we get this phthalimide. First of all, we take phthalic acid. This is phthalic acid. We treat this compound with 2 moles of ammonia. And we get this compound. This is phthalimide. Now in Gabriel phthalimide synthesis we will use this phthalimide. So let us see the mechanism of this reaction. This is phthalimide. We treat this phthalimide with KOH or NaOH we can use. NaOH or KOH contains OH minus ion. This OH minus ion will attack on this acidic hydrogen and we will get this type of compound. This K plus will get attached here because it contains positive charge. Now we will treat this compound with alkyl halide. This is alkyl halide. We know in this alkyl halide this contains delta positive charge and this X contains delta negative charge. Here is also delta plus and delta minus. And this is the slowest step of this reaction. So this is also called as rate determining step, RDS of this reaction. In the next step we will get this compound. Again we will treat this compound with base. So we will use here KOH. KOH contains OH minus and this OH minus will attack at any one of the positive carbon, because we know that carbonyl compound, in carbonyl compounds carbon contains positive charge and this oxygen containing negative charge. So this is the positive center, both of these. So this OH minus will attack on any one of these positive carbon center. So in the next step this OH minus will attack at this position. This bond will break this side and we will get N contains negative charge, R here, and this is OH. This OH minus attacks at the positive carbon. This bond will break this side, this electron will shift on nitrogen, so nitrogen contains negative charge. In the next step, here will be shifting of proton. This hydrogen will shift at this position, from this position. This is H plus transfer. There will be H plus transfer. This is called proton transfer. Now here will be minus charge, and this K plus will attack at this position. So here will be COOK. In the next step, there will be reaction with KOH, one more molecule of base. This OH minus will attack at this position. This carbon and RNH, and here will be negative charge because this bond will break this side. Both of these electrons will shift on this nitrogen, so it will be negatively charged here. In the next step, again there will be proton transfer. This H plus will shift on this negatively charged nitrogen. So in the next step, we will get RNH2, and here will be potassium salt. So this is our desired compound. This is 1 degree amine. This is the complete mechanism of Gabriel phthalimide synthesis, and this is the one of the most important reaction to synthesize 1 degree amine. But we can synthesize only 1 degree amine by this method, and this is the method to prepare pure amine, pure 1 degree amine. So this is the complete mechanism. I repeat again, this is phthalic acid. We treat this phthalic acid with 2 moles of ammonia. It gets converted into phthalimide. This is called phthalimide. 2 moles of water molecule will be get removed from here, and this will get converted to phthalimide. Again, after heating this compound, one NH3 molecule will get removed from here, and this will get converted to finally phthalimide. This is the phthalimide which we will use in next step. So this is phthalimide. We treat this phthalimide with 1 mole of base. We can use NaOH or KOH. Here we are using KOH. So KOH contains K plus and OH minus. This OH minus will attack at this acidic hydrogen, because this is acidic in nature. So it will get converted to N minus and K plus. H plus will be removed from here and K plus will get attached here. In the next step, we will treat this compound with alkyl halide. This is alkyl halide. We know in alkyl halide, halogens are more electronegative than this alkyl group, so it is negatively charged species. So this X minus will attack at this positive center, and this R plus will get attached at this position. Again, treating this compound with a strong base, we are using here KOH. This compound will be formed here. this bond will break from here, and both of the electron will shift on nitrogen, because nitrogen is more electronegative than carbon. So there will be negative charge. Now there will be proton transfer. This proton will transfer to this nitrogen and this compound will be formed. Again, treating this compound with strong base, this H plus will get removed from here and K plus will get attached here, and finally we get 1 degree amine. This is our desired product. So this was the complete mechanism of Gabriel phthalimide synthesis.